Okay, so that's me back. Now we're looking at asymptotes. So we'll start off with vertical asymptotes. Vertical asymptotes occur when f of x is divided by 0. It's undefined by division by 0. And let's just get into what I mean. I get into mean this. You know that x cannot equal -1. When that happens, we're going to get a 0 here and we're going to be undefined. What that means is that therefore there is a vertical asymptote at x equals -1. Okay, that's in fact an asymptote there. Now looking for my ruler that I've got here. What that means is that we have, there's my Cartesian plane, we're going to have a vertical asymptote right here. Okay? And what's going to happen is we're going to have our function approach it. Our function's going to be approaching that vertical asymptote both from this direction and from this direction. And if we want to know what's going to happen to our function as we approach that, we're going to have to take a look at some limits. We're going to have to take a limit as x approaches -1 from the left of f of x. And over here, we're going to have to take a look at the limit as x approaches -1 from the right of f of x. Now, these are left and right-hand limits. The only way to deal with them is using a chart. So we're going to make a chart. And we're going to make a chart. And yes, this is tedious. And yes, this is a pain. But yes, this is calculus using limits. So what we have to do now is I need to come up with my charts for here. So what I'm going to do is I'm going to work with x being less than -1. So I'm going to think about -1.1, -1.01, -1.001, and that's probably enough. So I'm on the left-hand side of -1, okay, but I'm getting closer and closer to -1. In here, I should be putting f of x. Now, if I look up and remember what f of x is, it's going to be x plus 1 squared. And when you crunch the numbers, you're going to see that you get -110 here. Well, you're going to get -10100. That's probably enough for us to determine that that's going to go on to -infinity. What that means is as I'm approaching this way, then my curve is actually going to turn and it's going to go down to -infinity. Okay, so that's the behavior as I'm approaching that vertical asymptote. What about the other side? -0.9, -0.99, -0.999. So I'm to the right of -1, but I'm getting closer and closer to it. So the x greater than -1, and it's x over x plus 1 squared. So when you do those numbers, you're going to come up with -90, -9900, and that's probably enough that we know that it's going to be going to -infinity, which means that as I approach it this way, I'm also going to take off down to -infinity. So what we have is a vertical asymptote where the limit as x approaches -1 from the left of f of x equals -infinity, and the limit as x approaches -1 from the right of f of x also takes off to -infinity. And that is our behavior at the vertical asymptote. Something like this. Okay, so now we need to take a look at horizontal asymptotes. I need to keep all these papers because I need to come back to them, all of this work, so I need to make sure that I'm putting them somewhere where I can get at them. And we're going to take at horizontal asymptotes. Okay, horizontal asymptotes occur at the extremes of the domain. So, domain. Yeah, okay. So we're going to take a look at the limit as x approaches positive and negative infinity of f of x. If that approaches a constant, then we have a horizontal asymptote. If that approaches infinity, then we do not have a horizontal asymptote. So we're going to take a look at this. It's the limit as x approaches plus and minus, I'm taking two limits at once, of x over x plus 1 squared. Now the way you learned to do this was to divide top and bottom by the largest power of x in the denominator. So we're going to expand out that denominator, x squared plus 2x plus 1, and we're going to divide top and bottom by x squared. That was the procedure for infinity limits. So it's x over x squared over x squared, plus 2x over x squared, plus 1 over x squared. Now, there's two different limits that I'm going to do here. I'm going to do the positive one, and I'm going to do the negative one. If they work out to two different answers, then that's great. Then that's what's happening at the two different extremes. They could work out to the same answer. Then the same thing's happening at both extremes. But I need to be aware that I'm taking this in both the positive and the negative direction. So if I put in a positive infinity, allow this x... Oh, wait a second. Before I even start that. Sorry about that, guys. I should do this. 1 over x over top of 1 plus 2 over x plus 1 over x squared. Okay. Now, if I put in a larger and larger and larger positive number into here, I'm going to get 0. I'm going to get 0, and I'm going to get 0. So this whole thing is going to go to 0. So the limit in the one direction is going to be 0 over 1. Now, the other one in the other direction is also going to be 0 over 1. Now my notation's really bad here because I've taken the limit and I've still written it, but I will just pretend for now. And so what that means is we have the limit as x approaches plus or minus infinity of f of x equals 0. That means you have a horizontal asymptote. And you have a horizontal asymptote at both extremes. So you have a horizontal asymptote at f of x equals 0 at both extremes. Just to send this point home, as x approaches negative infinity, f of x is approaching 0. And as x approaches positive infinity, f of x is also approaching 0. Okay? So what that means, if we take a look at this, I've got a horizontal asymptote at f of x equals 0. It happens to be the same as the axes. So there's f of x equals 0. And as x approaches positive infinity, I'm either approaching from above or I'm approaching from below. And over here, I'm either approaching from above or I'm approaching from below. And we're going to have to figure that out. I suggest using test points most of the time. So use test point. So I'm going to be able to put in a really large number out here. So let's pretend 100's a really large number for this. So that will be 100 over top of 100 plus 1 squared. So notice that this will be 100 over 101 squared, which is going to be 0.009, which you'll notice is greater than 0. If it's greater than 0, then it must be approaching from above. So this one goes away, and we know that we're approaching from above. Let's take a test point out here. F of negative 100, that will be negative 100 over top of negative 100 plus 1 squared. notice that that will give you an answer that's going to be less than 0. How do I know that it's less than 0? Well, it's going to be negative for sure. This is going to be a negative number inside. It's going to square to be a positive number. It's going to be negative divided by a positive number. That's negative. So it's definitely going to be less than 0. It's definitely going to be negative. And so we're going to be approaching from below. Which means that up here, that one's gone, and we're definitely approaching from below here, over here, because this is greater than 0. Above that horizontal asymptote, you know that it's approaching from above the horizontal asymptote. Okay? Below the horizontal asymptote. All right, so we're going to stop there, and then I'll come back and we'll take a look at the derivatives.